Alright guys, so I have my lemon tea ready and we're back at it. I'm saying that because this is the second time I'm making this video. You don't want to know what happened the first time. YouTube is not easy. Kindly, I would appreciate a like, a subscribe, or maybe a share. Anyway, let's get into it. So today we are going to Dockerize a full stack application. This is just a good way of learning Docker and the ins and outs and what Docker can do. So we'll just jump straight in, but before we do that, let me just get the project ready. I'll just pause this for now. Okay, so what I've done is I've just taken a project that was dockerized before and deleted every Docker file that was there so that we start from scratch. So I'm going to cd into my desktop. I'll cd into the YouTube folder. I will clear my screen and we'll just open the project with VS Code just to look around and see what the project is all about. So these are the files I've deleted because I want us to start from scratch. So the project basically is an HMIS. It has the front end running in Next.js. It has the backend running in Django, Django REST framework, and we will also be using Redis, Celery, and Celery Bit to run the project. So let's start from scratch. We don't have Docker. We are running this project without Docker, so manually, that is. So first and foremost, let's run our backend. So we'll cd into our backend directory. If you've worked with Django before, you will know that there's a concept of using virtual venv, but I don't think this is important for this part of the tutorial. You can just follow along. So we'll start by activating our virtual environment. So I'll do source venv activate. I will also link a video where I explained virtual environments and how to work with them for you in the description, or maybe in the whatever. So I have activated my virtual environment. As you can see here, the prompt has changed. Now inside my virtual environment, I'm going to install all the requirements. Now in Django, we store requirements in a file called requirements.txt. So I had installed this earlier, so that's why you see here requirement already satisfied. So once my dependencies are installed, we are going to run the project like that, and the project is running on port 8080. So we can just go there, can just go to admin interface and keep that open for now. Back in VS Code, so that is our backend. We also need our frontend to run, so we'll open another terminal. We cd into frontend directory. Inside frontend, it's a Next.js application, so we start by installing our dependencies with npm install. I think that will take a few seconds. Oh, okay, I had installed them already. So once that is done, we will run our project. So npm run dev. Is this thing recording? Okay. So that fires up our frontend, and our frontend is running on port 3000. We'll just close that for now. It's in development mode, so it takes a while to load. Now we also have two more things we need to run: Celery and Redis. So we'll scroll through the documentation to this part. So we will capture this and run it in a separate terminal. Now Redis is a separate tool. It's not really a Django library or whatever, so you just run it like that. What is remaining is Celery. So for Celery to work, we need to activate our virtual environment. So I will cd into my backend folder. I will activate my virtual environment, and then once that is done, I will run my Celery. So Celery is running. I think it's having issues connecting to Redis, but that is not important for now. So we have our backend, we have our front end, we have our Redis, we have our Celery. So you would imagine now managing all these services in production, it becomes very tedious, and it also becomes tedious managing the dependencies, because you would imagine, for example, for Django, we have let's pick some random dependency. Let's say Django 5.0.10.10. Now this specific project depends on Django version 5. You have another project, you've been given another task to work on a project that runs on Django version 4. Now if you have not set up virtual environments correctly, that will become a problem for you. You might get down into a rabbit hole that you will not dig yourself out of. So now let's try to run our project with Docker. So we'll close all this terminal, we'll close all these windows, and we just keep one, this one. Now a few things about Docker. Docker is basically like a virtual machine. It's lighter, smaller, faster, and easy to manage. So it's a virtual machine which runs your code in a separate environment. So what does Docker do? Docker performs several steps to achieving its functionality, and I will explain that with a Dockerfile in a second. So to containerize our backend application, we will go into the backend folder and create a file called Dockerfile inside. So this Dockerfile, I'll just copy the commands from a repo I had worked on earlier. So I'll just go to my profile, I'll go to EasyMade, backend, I'll just copy the Dockerfile here. Now this simulates what happens in the real world. You would rarely type all these things from scratch. Just find something somebody has done already, run it, check the image size, check the communication, check everything, how everything runs, and then you see if that works for your project. So we'll just copy that here. Everything looks good. Now here is what Docker does behind the scenes. Number one, it buys a new laptop. It installs an operating system to that new laptop as step number two. Step number three, it copies your source code into that computer. And step number four, it runs your code. That is exactly what's happening in here. So Docker will fire up a container, which basically is equivalent to buying a new laptop. It installs the operating system, the base operating system. It configures your laptop to run your project and only that one project. And then it creates a working directory. When you buy a laptop and you have something you want to run inside, you create a directory for it. And then we install other dependencies here. And then we copy your source code. So what this copy dot and then /app means, inside the current directory where Dockerfile is, copy everything that is inside there into the directory called app, which we had created up here as our working directory. And then once everything is done, we call an external command that will be responsible for running our application. Now this entry point.sh is right here, and inside it we just first check if Postgres is live, and then we run our migrations here. But there is no command to actually run the project. Now this is a different approach. You could also just get rid of all this, and inside here you could say cmd, and then you say Python, you're going with manage.py, run server, and then we say you want to run it on port 8080. And then that's it. So once you define these instructions inside a file called Dockerfile, you have to do two things. One, you have to create an image of your project, of your app, and then number two, you have to run your project. Now a little info about my environment. One, I'm using Zish, so it has this auto completion thing, so just ignore the characters in gray. It's Zish trying to autocomplete for me. In the terminal, I have an extension called lazy docker, which lists all my images, all my containers, all my images, and all my volumes. I think you can just download it from, if you just search lazy docker, it will show you where to get it. Anything else I'm forgetting about my environment? So in VS Code, I'm using an extension called Codium. I think it got renamed to Windsurf. It's just a small AI helper that helps me code faster. So we will build our image. So we'll do docker build, and then we say EasyMade API. We hit enter. expose cmd, run server, instruction cmd, unknown instruction. I think python manage.py, run server. Let's try with python 3. I'm not sure why it's throwing that error. Let's try with python 3. cmd. What is not happening? What is not happening? Okay, I have to troubleshoot this real quick. Okay, I'm back. I seemed to have forgotten a space right here. And that is what was causing all that trouble. So let's try to run again. That will take a while because it's performing all the steps. So it's buying the laptop, installing the operating system, installing the dependencies, copying our source code into the laptop, and then running our project. All the steps, we've defined them here. Now, while that is going on, we will continue with our front end. So we'll go into our front end. We create a new file called Dockerfile. Now, inside Dockerfile, we will copy. I like to just name it Dockerfile with capital D, just old habit. Inside our Dockerfile, we will define the instructions for running our front-end application. So I'll go back to our repo on GitHub, go to front-end directory, and then we want to get the Dockerfile there. I want to copy it, and then we want to paste it here. Again, it's the same things with how we were doing it with the backend. But you will notice here there are multiple from statements. So we start here with this one as base, and then, okay, what am I doing? And then we go to this one right here, and then we go to this one right here, and then now we run our project here. So this is what we call multi-stage builds in Docker. If you read the documentation, you'll read all about this there. Now, once that is done, we have all our instructions set up. So we'll go into our front-end directory, and then we build our container. So we'll just say Docker build, but instead of EasyMade API, we'll do EasyMade frontend, and then we hit enter. We give it a few minutes. It takes a while because now it's building everything from scratch. So I'm just going to pause this video and come back when these two are done. Okay, so it's still building. Backend is still building. Front end done. Backend not yet. Taking its sweet time. Anyway, oh, it's done. Oh, wait. This was the front end done. Now I'm not sure which terminal was I building the backend. Now it has disappeared. Wait, what's not happening? What is not happening? Anyway, so if you are watching up to this point, Tylee, shut up. If you're watching up to this point and you're wondering, okay, what is this thing called Docker? Docker is basically a software you install on your computer that will take the instructions you give it and fire up a container, which is sort of like a virtual machine, a smaller virtual machine to run your code. So if you go to Docker, you can get all the instructions for running Docker. Okay, it's a little bit confusing. My internet is not really that good. That's why my builds are taking longer. Anyway, so you go to the documentation, you'll see all this, you'll get to see what Docker is, how to install it. Now, I do recommend you install only Docker Engine, especially if you're on Linux. Docker Desktop is, I don't really like to work with it because it doesn't help you train your skills with Docker. Do I make any sense? So you might want to stick to Docker Engine, and the installation instructions are here. Now, after you're done with the installation instructions, don't forget to click on post installation so that you see how to add your users to the Docker group. And that's pretty much it. So it is a tool you install locally on your computer. You give instructions to it. It fires up a virtual machine for you, installs the dependencies, and then runs your code inside it Pretty cool stuff. Now back to our code. I don't know where my backend terminal went. I'm just gonna try and build it again and see how that goes. So it was docker build, and then instead of front end, we're going to say backend. Then we hit enter. It's going to take a while, I guess. Okay, so we are back to where we started, having multiple terminals, running multiple services. Now this is cumbersome. This does not, this beats the purpose of having Docker in the first place. Now the shortcut to doing this is we use something which is sort of like an extension of Docker called Docker Compose. So in the root of your file, of your project root, you're going to create another file called Docker Compose.yaml. Docker Compose, am I typing that right? It should be Docker Compose.yaml. Now what this Docker Compose will do, and I'll just end this for now, but I'll show you how to run your image. Here we were building our image, but now we want to run our image. To run our image, we will use Docker run instead of Docker build, Docker run. And then we give our image a name. We say name. It's going to be EasyMade frontend, and the image that is going to use is the image that we built earlier. So we built an image called EasyMade frontend, like that. You could give this any name. You could say you want it to be called client, and then hit enter. And then as you can see, what is this thing? And as you can see, our code is running. But now this is only the front end, it's not the back end. We have to do the same for the back end. You have to go and say docker run, and then we run the back end, which, you know, beats the purpose. So let's cd first into the root directory, and then inside our Docker Compose, I'm just going to copy an already written Docker Compose, and it's right here. So I'm just going to copy backend like this, and then inside here we are going to say services. So we'll start with the backend service. That looks okay. And then we take, okay, this is the wrong Docker file, this is the wrong Docker Compose. So we'll just get this backend here. And then we copy it here, and then we get the front end as well. Where is the front end? We get the front end here, and we copy it here. Now this is YAML syntax, which is very specific on the indentation that you can use. Now let's have a look at this at the code we've written, and I'm just going to send this to the right panel position right. Okay, I think this looks a little bit better. So what Docker Compose will do, it will keep record of all the containers you want to run, and then you can just run them with one command. So what are we doing here? First, we are specifying the context for Docker Compose for this specific backend service. We are saying inside the folder backend, there is a Dockerfile in there. I want you to use it to spin up our new container, and I want you to give that container a name, this API, and I want you to use this command when the container runs. Now this is different from what we were doing before. As you can see here, we're just running our container and spinning up everything at once, but we want to use entry point.sh. So we'll say run chmod, and then entry point.sh, and then entry point.sh. That's what we need. Now inside here, we'll just skip all the other lines and just run uvcon. Now here I'm not using Django's inbuilt run server because our application uses WebSocket, so that is why we are using uvcon here. And then what I'm doing here is there's the concept of volumes. So here I'm saying there's a folder called backend where Docker Compose is. At the root here, there's a folder called backend. This folder is what you're referring to. Now I want you to take everything inside that folder and sort of like copy it or sync it into the folder called app inside the container. Now this folder right here, you might have remembered it from when you are defining our project. We said our working directory is app. Now this is where we are copying everything from our current root directory. And then we are mapping our ports. So what we are saying here is that port 8080 on the host will be mapped to port 8080 on the container. And then we specify our .env file, and then we specify our restart policy. You can read all about that. And then we specify the network to use. Now I like to put this in here because I like to know the infrastructure very well, or on which my projects are running on. But if you specify a network here, you have to come to the end of the file and you specify the networks there. So just say it's called MKS and the driver is bridged. All these other things just I don't think we need it. Okay, now once that is done, we'll just go to our terminal, and then we just run frontend and backend using one command. No more firing up virtual environments, no more installing dependencies separately. With this just one command, our front end and back end will be up and running. This will take, oh okay, we already have the images, so our front end is working here. We can just check it out. Trying to click okay, so our front end is running. Let's confirm if our backend is running as well. Our backend is right where give it a few seconds. Oh, is it running already? There are a few errors, but I think we can work on them later. Okay, so our backend is not finding Redis. Like I said, we're using Redis and Celery, so we need to add Redis and Celery as well. So we'll just grab them from here. Just going to grab Celery and Celery bit first. We put them in here, and then we will grab Redis. Redis is right here, and then we just put it in here. Okay, so Redis is required by our backend, so we might want to start with Redis first. Let's kill our terminal. Okay, so once that is done, we will again fire up all our containers and see if our backend will be running. It's running migrations. Okay, so it's running on port 8080. Let's try and see if okay, our backend is running. Right, so now this is the beauty with Docker. With just one command, we fired up our entire full stack application. No more running each service on a separate terminal. Now like I've said in previous maybe video, a Docker container is basically like a virtual machine. So let's see how many virtual machines are running currently. Now the tool I use here is called Lazy Docker. It shows me all the containers that are running. As you can see here, I have EasyMade backend, EasyMade frontend, EasyMade worker, Postgres, and all that. But we want to SSH into, I'm using the word SSH loosely to mean that we want to sort of like exec into a container. So we want to check out the backend container and create a user inside. So we'll do docker exec. But here we are working with, what name did you give it? We have to use the specific name. We gave it the name API. So right here we will say we want to exec into API. Now you master this command. It's the command you use to open a container, to open a container, or to SSH into a container. So you just do enter. Now we're inside the container. As you can see, my prompt has changed. So inside the container, we want to create an admin user. So we'll say manage.py, create super user. Create super user, is that the correct command? And then we'll say super user is admin@mail.com. That email already exists, so you say admin3@mail.com, and then we'll give that user a password, a super secret password. Then super user is created successfully. So we will try to log in admin3@mail.com admin, and we have successfully logged into our service. Now all this is running in from the container seen here. We can also check how many we can check which files are inside the container. We can do ls-l and we see all these files inside the container. Now an interesting thing, I want you to pay attention to what happens when I do something like ifconfig. It of course shows us that the IP address, I'm looking for the IP address. Our IP address is this. Now that is 1902. Now this is not permanent. When you run this container again, it will get a different IP address. So inter-service communication should not be dependent on the specific IP address used by a certain service. So for example, in our front end, let's check at where we define the backend URL. So right here is where we tell our backend, where we tell our front end that our backend is running right here. Now you might notice that we are using the container name, not the IP address as we conventionally use when you are not using Docker. It's because if you specify the IP address of the backend container here and the container restarts, it changes the IP address and you will not get this. That is one thing to look out for. The other thing to look out for is that container volume is not permanent. As you have seen, we've used admin3@mail.com to log in, but all this data is stored inside a volume, and I will show you here. You see Postgres has a couple of volumes here. There's a couple of volumes, and then we have this easy-made Postgres data. Now when this is deleted, you will not get access to your data. So that is also something else you need to look out for when working with containers. There's something else. I'm just trying to open up my notes here to see what I've left out. Okay, so a couple of commands you need to master to work with Docker, but all of the commands can just be found from here, Docker help. This will tell you all the commands you can use. There's attach, commit, cp, create, blah blah blah, all that stuff. You can play around with all those. If you want to check how many images we have, we can just do docker images ls. Found matching ls. Did you mean docker image? Oh, okay, I typed images. That should be docker image ls, and it tells us all the images currently running on our system. Now something interesting to pay attention to is there's an image here tagged none, which is consuming a lot of space. This you might want to do away with them so that you don't pollute your file system. Now this is what we call dangling images in Docker, images that are not connected to a container. Remember I've said the first step is you define a Dockerfile, and then a Dockerfile will package your code will package your application into an image, and then that image is what you run, and the image in a running state is what you call a container. So there are images that are not connected to any containers, so we remove them. The command to remove them is you can do docker image, and then you pass in that flag, and then we pipe that output to xargs, and then we say docker rmi. Did I type that correctly? Or what did I do? Docker, this should be images if I'm not wrong. Okay. So what that will do, it will must be forced image. Now let's check if our images are still there. Okay, so the non-tagged image is gone, but we still have a couple of images here, and as you can see, these images are related to the current containers running. So the only way to remove this is if you kill your containers or if you stop your containers. So that's basically it on Docker. Of course, these things, DevOps is a highly practical field. You have to experiment a lot, pay attention to the size, the performance, the time it takes to build such containers. You can try with this type of a container. You can try with, for example, this Dockerfile here gives us an image. Let's have a look at our image. It gives us an image image frontend, it's 198 megabytes. But what if we try with without multi-stage build? So we will get rid of all this. We'll get rid of all this, and then just do that, and then we can say work directory is app. Now once inside app, we can copy the package.json, and then we copy the source code. Once that is done, we can install our dependencies, npm install, and then we can build our code. No need for that. Then once that is done, we can just run our project. So we'll say cmd npm, I'm typing in caps, npm start, like that. Now let's see how big this image will be. So again, we will fire up our containers. Just give it a minute. Oh, okay. We need to rebuild. If you do Docker app, it will use existing images, so it will disregard anything you type here. So you have to pass in the build flag so that it rebuilds your containers. So just do that and give it a minute. Okay, I think I'm just going to pause, and then I'll come back when that is done. Okay, so that took its sweet time. Now let's look at the image this Dockerfile has created for us. So we'll go into lazy docker and you look for front-end image, and it's right here. And as you can see, it has given us an image 2.67 GB. Now if you can remember, the previous image was, I think, around 189 megabytes. Now this one is 2670 megabytes. It's way too big. So this is the level of experimentation that you need to do when you're working with containers to see which one works best for you. So somebody, maybe this, under some very weird circumstances, somebody might need an image 2.6 gigabytes big, but in production environments, I highly doubt that is needed. So with DevOps, you have to experiment a lot, you have to practice a lot to see what works for you. Again, just to do a recap of the steps for containerizing an app. Step number 1, you have to make sure you have Docker installed. You just go to the Docker documentation, you follow the steps for installing Docker. Step number 2, you create a Dockerfile. Here we've created a Dockerfile for our backend, and we've given the instruction that needs to be run. And then you create a Dockerfile for your front end. Again, we give the instructions that will be run. Once that is done, instead of building the image and then running the container separately, we just use Docker Compose to put them sort of together. And then now from here, we can just run everything with one command, and everything is running okay. So I think that's it for this video. If you do like the content I put up here, consider giving me a like, subscribe, share it with your friends, people who are struggling to understand these things. I personally feel like when you use a real world use case approach, you understand it way better than if I just told you this is how you Dockerize an application, this is how you run it, and then that's it. But when I put it together like this, for a full stack application, you get to understand exactly how things go behind the scenes. In a future video, I will dive deeper. I will containerize I will build the images and push them to a remote repository so that other people can pull and run on their end without any, it runs on my laptop kind of back and forth. Thank you very much, and I'll see you in the next one.